So Friday we talked about sketching a graph, right? And we talked about, what else did we talk about Friday? Help me out. What did you have to do on your homework? Oh, the type, the leading coefficient, the constant. We had to sketch the graph and identify those parts, right?
All that good stuff.
Pretty easy, right? I hope. We're going to add the rest of our analysis steps on here today. All right. Analysis continued. One thing that I'll throw out there that's a part of the analysis that you should already know is your domain and range. Those are two steps in the analysis. Remember I told you, I think, how many did I tell you how many steps? 10, 11, something? If you want to turn that desk, you're more than welcome to, because it's kind of an awkward angle. So domain and range is going to be a part of that. So let me just show you quickly. Let's say I graphed this. By the way, what type of function is that? Looking at the picture. A cubic, absolutely. Every degree is adding another hump. What would, and I'll put you some axes on here, what would the domain of that yellow function be? Just looking, you can visually look at this and tell. Domain. Domain goes which way?
Left to right.
Left to right, that's right. So what's the domain?
Negative infinity to positive.
Negative infinity to positive infinity. Does that confuse anybody? A lot of us got kind of stumped with domain and range. How about range here?
Negative infinity to positive.
Absolutely. Negative infinity to positive. No, I'm fixing to show you one that's not. Remember when we did parabolas, the range was impacted. What if it looked like what's the domain here?
Negative infinity to positive.
Left to right. Remember, domain is left to right. How about the range?
Negative infinity 10.
Bracket or parenthesis?
Bracket.
Why?
Because you need to pass that.
There's actually a point there, right?
Yeah.
It includes that point. We remember domain and range now? Okay, let's talk about in behavior.
Hold on, can I take this?
Yes. All right, so keep a running tab. I'm going to make a list on the board over here so we have it. Well, is somebody eating my record? There's two right here. I'm just losing my mind. Let's see. For our analysis so far, we have a sketch. We have the type, leading coefficient, and constant. And I'm going to lump those all under one category here. And now we've added domain and range, but nothing new now, right? Right, Miss McGee?
Right, Miss McGee.
Thank you. Oh, and you know what else we need to put? Beside constant, I'm going to put in parentheses, really, that's my y-intercept is what I'm finding. Right, because the constant without the x there is the y-intercept. Okay. Ready for the new stuff?
Okay.
Okay. We're going to talk about in behavior now. Okay? So if you're keeping up on your analysis steps, this is about our fourth step here, okay? Analysis or in behavior. How many ends does a graph have? 2. 2? 34? 2. Okay. End behavior is where we describe what both of those ends are doing. Okay, so I think it's easiest before I just tell you how to do it if I show you a picture of a graph and explain what it is end behavior is doing. So if we take one of these same, in fact, let's take a nice little cubic here. Since it has 2 ends, the end behavior description is going to have 2 parts. Okay, it's going to have a right end part that I'm going to say as x approaches, and I should actually tell you that. This little arrow means approaches. As x approaches, which means it gets close to positive infinity. So if I'm talking about x going to positive infinity, I'm talking about x going which direction? Which way does x approach positive infinity?
Right.
Right. Okay. So as I look to the right, well, which end of the graph is the right end of the graph?
The right.
The down arrow.
The up arrow? Okay. As you look at the right side, is the graph going up or is it going down? So that means y is also approaching positive infinity.
Wait, how is X?
X is left and right, y is up and down. As you look right, the picture's going up.
But why isn't it facing down?
There's 2 ends here. This is one of the ends. Now we'll describe the second end in just a second. It should have 2 parts to it. So for the second, are you raising your hand for me? Oh.
Up and down.
As we look to the left, so is the left end of the graph going up or is it going down? Down. That's negative.
So there's going to be 2 things?
Yes. 2 parts for 2 ends because each graph has 2 ends. Sam, are you taking notes on there?
The first one?
Are you taking notes on there or playing a game? Okay. I know. Kudos to you for telling the truth.
She can see that.
I couldn't see it.
No, like you can see it on the computer.
I don't have it pulled up right now. I'm doing notes.
Okay, so one of them, the first one's for the right side and the other one's for the left side?
Correct.
Right.
Okay. Now here's the neat thing about it. How many different scenarios could you make with the right and the left side?
4.
4, right? Either both ends are going to go up, both ends are going to go down, one's up, one's down, or vice versa, right? There's only 4 scenarios. To figure those 4 scenarios out without even graphing, because it's easy to look at a picture of the graph and say, oh, this is what it's going to do. But we're talking about some general type analysis without having to graph it that we can do. So we can classify that, and I'm going to do my 4 scenarios here. Okay, by the leading coefficient and the degree. Leading coefficient and degree. Leading coefficient is the coefficient that's hooked to the biggest exponent. Degree is the biggest exponent itself. 4 different scenarios. I'm going to say if the leading coefficient is positive or negative. And remember, positive and negative, that's your A out front. That's what flips it, right side up or upside down. So that makes sense that that would impact. So positive or negative. And then my degree could either be even or odd. And if you think about it, things that are even degree, like quadratics, both ends go the same direction, right?
Mm-hmm.
Both point up or both point down. Or odd, like a line, they go off in opposite directions. All right, so I've got even, odd, even, odd. So everybody wants to know if they can use the chart on their test, and the answer is no, because you should be able to derive this chart if you think about it, because everybody in here should be able to think of at least one example of some polynomial that is of even degree with a positive leading coefficient. What does that look like? What's the easiest one look like? Even degree, think about powers of 2, 4, 6, 8. What's the easiest power we know? 2. That's a what? That's an even, but it's called a
Coefficient.
A degree of 2 is what's the type?
Quadratic.
Yes, thank you. A quadratic, which makes a parabola, right? Yes? All right. So I know that these evens, an example of an even is a quadratic. If the front number is positive, it's happy and goes up. If the front number is negative, it's sad and goes down, right?
Yeah.
If you have a picture, the end behavior is easy. Remember there's two parts. As x approaches positive infinity, what does the graph do? What's the right side of that graph do?
Positive.
Positive infinity. What's the left side do?
Positive infinity.
Positive infinity.
That's weird.
It looks weird, it's written weird, but I really think you already know this. The generalization is any polynomial whose degree is even and leading coefficient is positive is going to have this end behavior. No matter what's happening on the inside and between the two ends, both ends are going to point up. Does that make sense?
So why does x
For the
equal
left,
negative
why is that
infinity?
negative infinity?
And then
Oh, never mind, because that's coming
X-
from the left.
Yeah, x to positive infinity means right side, so that would be this end right here. X negative infinity is left side, so it would be this end.
Then why is it the other end negative?
Both of these describe the y and tell if it's going up or down. Do the arrows point up or do they point down? Both of them point up. Okay? So same situation here, but if it's negative, which way am I going? The right side's going what? Negative. The left side's going down. Both of them go down. Does that make sense to everybody?
Yeah.
So literally, whenever I ask you for the end behavior of a function, you think about which square it would be in, and you copy both of these mathematical sentences for the end behavior. Does that make sense? Yes.
When's the test?
Wednesday.
This Wednesday?
This Wednesday.
On what? What?
Chapter 2. Which started with properties of exponents. We'll review tomorrow. All right. Let's do the last two squares here. Tell me what the easiest odd degreed polynomial is that you can think of.
3.
Even easier. 1. A degree of 1 is what type of polynomial? Linear. Lines are easy, right? If the leading coefficient is positive, the leading coefficient in a line is the what? The equation of a line looks like this.
Yeah.
This is my leading coefficient because it's hooked to the x. So I'm describing the what? Slope. So I'm looking at a positive slope or a negative slope as examples. Okay? Understand these little pictures I'm drawing are just ways that help me figure out what the end behavior is. To look at the picture and determine the end behavior, but the end behavior is general. Okay? All right. As x approaches positive infinity. So I'm looking at the right-hand side of the graph. The right end of the polynomial, what is it doing? Is it going up or down? Up. How about the left? Down. No problem. Your school pictures, you need them. Your mom might want to order some. Show your mom. She might want to order them.
Nah, hold on. We don't order pictures.
She might at least show her
We
Tyler.
get the football and baseball pictures. That's about it.
Hey, Tyler, you have fun this weekend?
Let's do the last situation. As x approaches positive, which way does the graph go, up or down?
Down.
Down, 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 baby. How about the left?
Will X always be positive?
No.
X is always going to be up. You're right, it's up. X is always going to be one positive, one negative, because you're talking about the right side and the left side.
Oh,
Wait, what?
I got it now.
Then, wait.
X, you're always going to have one positive, one negative X, because you're talking about the left side and the
So why
right
depends
side.
on what side we talking about?
So look at this.
So the left side is going up and the right.
Look at that polynomial. 5x to the 12th plus, it really doesn't matter what else is plus, because in order to determine in behavior, I only have to look at that very first term. I have to decide positive or negative, even or odd. Which scenario does 5x to the 12th fit into?
Positive.
Positive, even.
No.
5 is positive. The leading coefficient is positive.
But it's not even.
12 is even. The degree is even.
Oh,
It's
that's
the
what
degree,
talking
yeah.
about. Okay.
Okay? So what that tells me is, I don't know what's happening in between. I know that at the end of the day, both ends are going to point up. This might do all kinds of stuff in between. But after everything's said and done, the two ends are going to point
Which
up.
side is X? So you could switch. So you could switch that order around to have X. X is equals negative infinity instead of having the first one there.
What?
You could switch.
It doesn't matter which one goes
All right,
first.
that's just. It confuses me because we were always.
All right, other questions about in behavior? Your book, if you go back and look at the book, they do theirs backwards on in behavior and I don't like it. But whatever. All right, y'all ready for critical points? Because that's the last thing.
Yes.
You say that now.
Oh, this is a hard one. That's why I got critical. Oh my. He's the hardest.
So which end is X and Y?
Kelly, you heard that?
Which end is what?
You heard that?
Which end is
X describes left and right. Positive is right, negative is left. Y describes the up or the down of it. All right, let's talk about some critical points. The first one you've already done. There's 3 types of critical points. Zeros or roots. Okay. Some of your calculators call them different things. All right, but it's same difference. What is the zero of a function? Absolutely. X-intercepts, where it crosses the x-axis. We've talked a lot in here about zeros and x-intercepts, right? Okay. But we haven't talked a whole lot about how to find them outside of PRZ, factoring and solving and that kind of thing. I want to show you how to calculate them exactly on your calculators real quick. So if you will, get out your calculators. No, find my calculator here.
It's hot.
Do you have another calculator?
You can check.
Where?
My middle desk drawer there. All right, let's take I forget I can't use it. I don't know that they're graphing though. That one doesn't work. All right, let's put a function in here.
Oh, does this work?
Yeah, but that's an 86. It's a little different.
What is it?
No, that's not a graphing. I'm telling you, I think somebody ran off with my graphing, my 83.
How great.
38.
I haven't heard these before.
That's fine. All right, let's graph. Let's do x to the 4th. Minus 6x to the 3rd. Plus, 3x squared.
To the second, isn't it?
Yeah. Plus 10x. Minus 3.
Wait, so where you go?
Y equals. All right. As soon as everybody's got that in their calculator, I'll show you. All right, I'm going to go and graph it.
You didn't put the center right, I think.
Then the other, the top one.
Oh, you put negative.
All right. I cannot see everything on this one that I need to see. Do we agree?
That's not what I got.
X to the 4th minus 6x cubed plus 3x squared plus 10x
Okay, you're going a little fast.
minus 3. Is that what I
I
have?
have that down, but
I got to adjust my window some. What's your window setting at though?
My window is at negative
shape
88.
resistant 3x.
This is why I was telling you, you really need to, oh look, that's wrong too. There we go. I still can't see quite everything I need to see. Do you agree? Yeah.
So zoom out.
Exactly. Adjust my Y's. Which Y do I need to adjust, the max or the min? Minimum. I need to see more at the bottom,
I
yes?
just zoomed out. That's all.
Well, we gotta see more at both. We gotta just both.
I'm going to change this to negative 15. And remember, this is what you were supposed to be doing in your homework also.
The y max.
I still can't see the bottom of that graph there. Guys, y'all pay attention. Is it? All right, so I'm going to do negative 50.
Negative 50.
Y max.
You saying the Y max too?
There we go. Nope. But I am going to cut some of that excess x off there. It's a little much. I think I'm going to go from negative 3 to, what, 6 maybe?
Negative 3.
This is a pretty good picture, I think. What you think? Okay. As you look at this, you will have to, on all your equations, you will have to identify, and part of the reason of writing your window down is whenever you go back and graph these to find these critical points, you have your good window already set up for you, so you just enter those in. Okay? So, I want to calculate the zeros, yes? How many zeros do you see?
1.
4.
How many times does it cross the x-axis?
4.
4. All right, here's where if you have a TI, which most of us do, you have to stay with me. Now watch what I do. If you go second trace, which is calculate,
So what?
look at the options, second trace.
What, that second?
Mm-hmm. Trace. Oh, mm-hmm. All right. Do you see the 0 option there?
Yeah.
Choose that.
Is it enter?
Mm-hmm. Now it tells you left bound. That means, do you see the little blinking? I call it a spider. See it there? That's trailing through?
Value 0, minimum max.
Mine ain't trailing through.
0. Hit left and right. Hit your left and right arrows here.
It doesn't.
Keep on going. If you look at the bottom, guys, this is where everybody messes up. This is on your test, and it's completely calculator dependent, so I need you to know how to do it, okay? If you bring up your calculator to me and say, Miss McGee, will you show me how to do this on your test? I'm going to say no. That's what I'm testing you on, okay?
Can't fly us like that.
So you need to pay attention. Does everybody have a spider on their graph?
Yeah.
Yes, but I don't see the thing at the top.
Okay? Yes. I'm fixing to show you. All right, now, notice it's asking me left bound, okay? That is saying, shh, girls. That's saying go to the point you're trying to find, okay? And then go to the left of it, okay? What the TI makes you do is give it a range, okay? So I'm going to pick this far left point. My general rule of thumb, my general rule of thumb, I'm pretty close to it right there, right? But I'm not exactly. Make sure you clear it to the left by hitting the left button. Left, left, left. 3 times and hit enter. Then it says right bound. So what you want to, you just want to clear that. You want to be to the left-hand side of it before you hit enter. I want to make sure now I'm to the right of it.
I hit enter.
Hit enter.
Yeah.
Now look at those 2 arrows that are at the top, because that's what I want you to see. Do you see these 2 arrows? Look.
This right here? Yeah, I see it.
All right, wait. Don't click anything else yet. I want you to understand why they're there. You didn't change the sign. It says no sign change. All right, look. Do you see my 2 arrows? Everyone, do you see the 2 arrows?
Yeah.
The TI makes you put a range of numbers, and it says that somewhere in between these 2 arrows on the graph, it's looking for where the graph crosses the axis, okay? It's looking for a 0 between these 2 values. You have to give it those 2 values, else it doesn't know where to look. The first one has to be further left than this one. Then when you hit enter, because it says, do you want me to guess? You hit enter, and there's your exact value of your 0.
Hold on, what happened to mine?
You didn't go left and right. Your signs didn't change. Is that my calculator?
Yeah. I was borrowing it.
There it is.
Oh, somebody was asking me for it? Yeah, I told you I had it Friday. You remember that?
You can't borrow it at home.
Second.
So this 0, now remember, look, this is scientific notation. Your pixels in your calculator throw it a little bit, okay? Let's calculate this one together and see, because some of you are getting some arrows. Second, yeah. Try it again. Try the 0. Watch what I do. And try it again. Because something's happening when it's telling you left bound, you're not going far enough left. All right. I always start about where I think it is, as close as I can get the spider, about right there, okay? And before I hit enter, it's telling me left bound, so I want to click it 3 times to the left. 1, 2, 3. Now I can hit enter. Now it's asking me for right bound, so I'm going to go back to that 0, and then I'm going to go right 1, 2, 3 clicks. And hit enter. Do you want me to guess? Yes, I do. The other points we're fixing to calculate are done the exact same way, so you need to understand this method.
What?
So 0.2887 is a 0 of this function also. Did you get that time, Brianne? Okay. It is confusing with the left and the right, but the more you practice with it, you'll get it.
How many
All of them.
All you gotta do is hit second and third.
Oh.
to the x. To the right bound.
3. 3 is good. 3 from the critical point. 3 from the critical point.
Oh, you just need the graph. You stupid.
All right. We're also going to calculate the other critical points in the same way, but I need to tell you what those other critical points are.
I thought we was done.
No.
I'm a few critical points.
All right. The other critical points we have are maximums and minimums. Now, I hope from your experience with quadratics and parabolas that you understand what a maximum or a minimum is, right? It's like where that vertex is. But what if, I don't want to do that, wait. What if I have something like this? What do you think it has? A max, a min, both, neither?
It has both of its smallest and its biggest.
I heard a maximum. I heard 2. Remember that happens whenever it changes direction. So every time it changes direction, there's also a minimum. Now, these are 2 different types. All right? This is what we call a relative or local maximum, I'm sorry. Whereas this is what we call an absolute maximum. Why do you think that is?
Because it's the biggest.
The graph never goes any higher than that. That is absolutely the highest the graph ever goes is the absolute max. That graph is bounded at that point. Cannot go any further. So looking at the minimum that's there, do you think that is an absolute or a relative? Relative. Why? The graph goes down forever, so it's a relative minimum. Does that make sense? Okay, so back to our graph. What does it have? An absolute minimum. What else does it have? Absolute minimum's happening right here. Relative or local
It has
min and max.
there's an absolute minimum.
There is an absolute minimum. Okay. Yes, correct. So let's calculate one. And if I show you one, I think you should be able to get the rest of them because it's the same process. Again, I'm in second trace. Look at there. Look, minimum, maximum. Okay? I'm going to choose, we'll choose minimum because it comes first. Again, put the spider close to where you think that minimum is occurring. So I'm going to come left here. I'm going to say this is fairly close to where it bottoms out, right? This is something you cannot estimate. It has to be exact. Okay?
So at each peak is where it's supposed
Correct.
to put the left bound and the right bound.
Well, no, what you want to do is you want to take your spider and put it on the change of direction point. And whenever it says left bound, you want to 1, 2, 3 clicks left at least. Hit enter. Go back to that point and then 3 clicks right.
So are you doing the same thing you just did?
It's the same process. What it's doing now is it's saying in this interval of numbers, I'll find the lowest point. So
Wait, where?
I haven't guessed yet.
No.
Huh?
Can you just press enter again?
Yes.
Oh, I got the
You
same
can still
thing.
click trace or
Second trace.
Except mine is rounded.
I'll say
Yeah.
yes.
No sign change.
the first one.
You
just
didn't
trace.
go. You didn't go far enough. You went right first instead of left first. This is no sign change.
I'm talking about
All right, because I want you to have time to do this in class, okay? Or at least begin it. And especially because some of us don't have a calculator right now. Here's what you